Hi everyone, for today's lesson we are going to learn about how to solve triangles using the law of cosines. Before we get started, I would like you to please go ahead and complete this really quick form-up where I want you to find the area of the triangle given that the triangle has the following dimensions. One side is 80 feet, the other side is 80 feet, and their included angle is 110 degrees. So please make sure that you go back into your notes if you forgot what that formula is. Use the correct formula in order to find the area. Pause the video as you are solving this, and when you have an answer, please restart it and we'll see how well you did. Alright, so once again, this area formula is area is equal to 1/2 B times C times the sine of angle A, and that angle A is our included angle. So if I were to call this A and I would call this B and C, here is little b, here is little c, and I'm going to be using this formula. So I have my area is equal to 1/2, my side, which is 80, times my other side, which is also 80, times the sine of 110 degrees. And so if I were to put that into my calculator exactly as I see it, I find that my area is equal to 3007.02, and that's going to be feet squared. And our units are always squared whenever we're trying to find area. So our learning target for today is for you to be able to say, I can use the law of cosines to solve any triangle given side, angle, side, and side, side, side. So in 13.5, we learned how to work with the law of sines to help us to solve triangles when we were given angle, angle, side, angle, as well as side, side, angle. So now we're going to be working with side, angle, side, and side, side. So when we were working with the law of sines, we were given information that was the two of a kind, meaning we had an angle A and a side A, or an angle B and a side B. Or we had two angles and it was very easy for us to identify the third angle so that we could use the law of sines. This time around, for the law of cosines, we are going to receive one of each letter. And each letter is going to have two sides included. So it's not going to be where you're going to receive two angles. This time around, you'll receive at least two sides, and you might receive an angle, or at least two sides, and you might receive another side. And all of those are going to be different letters. So you might receive little a, little b, and angle c. Or you might receive little a, little b, and little c. Regardless, you'll end up with side, angle, side. So the formula for the law of cosines goes like this. Our labeled triangle will be the exact same as what we've been working with for the last few lessons. And if we wanted to find a missing side length, this is the best approach for us to find a missing side length. We would use the formula a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. If we wanted to find what little b was, we would use the formula a squared plus c squared minus 2ac times the cosine of angle B. The thing that I want you guys to know about these formulas is that a squared, b squared, and c squared represent your unknown side. And then the other two sides that are given to you will be squared and added together, just like the Pythagorean theorem. It's like the Pythagorean theorem is kind of embedded inside of this formula. And then what you have to remember is the 2bc times the cosine of A. So just remember that whatever two numbers that you have right here are going to be multiplied by 2, and we're going to be subtracting it. And then we have the cosine of whatever is the opposite angle. So if we start with a little a, we end with an angle A. If we start with little b, we end with angle B. If we start with little c, we end with angle C. So it's minus 2 times side 1 times side 2 times the cosine of your included angle. And notice that I use the word included. And that's because law of cosines works really, really well if you are given side, angle, side. The reason why it works so well is because you can put all of those numbers into your calculator very easily to come up with just a number, and then you take the square root of that number and boom, you have your missing side length. So it's best if you use the law of cosines in the way that it's originally structured if you are given side angle side. But notice I said you can also use this for side, side, side. So what I'm going to show you is a shortcut to try to help you avoid making mathematical errors. What I've found is that whenever students solve for an angle, meaning you have side, 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 so that means you need to find your angles. And whenever they solve for an angle using this formula, somewhere along the lines, a lot of times kids make mistakes. So what I'm going to show you is a shortcut in order to save you some time. It doesn't look like a shortcut what I'm about to show you, but believe me, it is. So this is what happens if you're given side, side, side. I'm going to work with the first formula. That is going to be a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. And what I'm going to do is I'm going to solve for angle A, because in side, 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 I don't know any of my angles, and I need to find them. So let's say I want to find angle A. The first thing I'm going to do is I'm going to get this term alone, get the minus 2bc times the cosine of angle A alone. So I'm going to subtract b squared from both sides, and I'm going to subtract c squared from both sides. And when I do that, I end up with a squared minus b squared minus c squared is equal to negative 2bc times the cosine of angle A. And when I divide both sides by a negative 2bc in order to get the cosine of angle A alone, I now have like this negative that's in the denominator. And just like we've learned whenever we worked with quadratics, we don't really want our leading term to be negative. We don't want a negative to be in our denominator either. So what I'm going to do is I'm going to simplify this fraction by dividing out a negative 1 from every single term. So what I mean by that is if I were to divide an a squared by negative 1, I'm going to end up with negative a squared. But if I divide negative 1 out of a negative b squared, I'm going to end up with a positive b squared. And if I were to divide out a negative 1 from a minus c squared, I'm going to end up with a positive c squared. So I'm going to end up with a positive b squared, a positive c squared, and a negative a squared. So only one term in the numerator will be negative instead of 2. This will be divided by, I'm going to divide out a negative from our denominator, and negative 2 divided by negative 1 is a positive 2bc. So we went from all of these negatives to now having more positives just by dividing out a negative from every single term. And you're allowed to do that as long as you are consistent amongst all of your terms. And that's going to be equal to the cosine of A. So now how do you get cosine alone? Or how do you get the measure of angle A alone? Well, the way to get rid of cosine is with cosine inverse. So I'm going to take the inverse of each side, and that would mean that the cosine would be detached from angle A, leaving us with the cosine inverse of b squared plus c squared minus a squared divided by 2bc is equal to the measure of angle A. Now this formula works for all of the other letters as well. So if we wanted to identify what the measure of angle B is, the measure of angle B is going to be equal to the cosine inverse of a squared minus c squared, or a squared plus c squared minus b squared divided by 2ac. And the measure of angle C, that's going to be equal to the cosine inverse of a squared plus b squared minus c squared divided by 2ab. So the shortcut, the thing that I want you guys to know and to study and to remember, is that what are we trying to find here? Well, we're trying to find our missing angle. So our unknown angle, whether it's A, B, or C, is going to be equal to what's given to us, which is going to be the cosine inverse of our side that's given to us. So it's going to be side 1 squared plus side 2 squared minus your opposite side. So notice that if we wanted to find angle A, we always subtracted a squared. If we wanted to find angle B, we always subtracted b squared. If we wanted to find angle C, we subtracted c squared. So we're subtracting the opposite side squared divided by 2 times side 1 times side 2. And that is our general formula. So now we're going to go ahead and use this formula and whenever we are working with side, 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 and we're going to use the original law of cosines formula when we are given side, angle, side. Now, once you identify what a missing side length or a missing angle is, we will now officially have two of a kind, and then from there you'll have choices. And we'll talk about those choices in just a second. So for example number 1, it says solve triangle ABC, where we are told that little a is equal to 7. Hopefully this becomes clear. Here we go. Little a is equal to 7, little c is equal to 12, and we are told angle B is equal to 26. So this is side, angle, side that we are given. So since we are given side, angle, side, it will make sense for us to find our missing side first, and then from there we can make a decision about what we want to do. So I know that I want to find what the measure of angle A is, what the measure of angle B is, and what the measure of angle C is. And then I want to find what little a is, what little b is, and what little c is. So I know that the measure of angle B is 26 degrees. I know that little a is equal to 7 units, and little c is equal to 12 units. So I have to identify my unknown pieces of information, and I would probably start off by identifying what little b is first so that I can have officially a two-of-a-kind situation. So I'm going to be working with identifying what b is first. So I'm going to write b squared is equal to a squared plus c squared. So I'm going to use our formula up here. So it's going to be a squared plus c squared minus 2ac times the cosine of b. So I'm going to write a squared, which is 7 squared, plus c squared, which is 12 squared, minus 2 times 7 times 12 times the cosine of angle B, and angle B is 26 degrees. And make sure that your calculator is in degree mode before you even get started. What's really cool about this is that the entire right-hand side of this equation is a number. And you can put that into your calculator exactly as you see it, parentheses and all, and you'll end up with your answer. So if I were to put into my calculator 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 26 degrees, I'm pressing enter, and I end up with 42.00260022. So I'm just going to write 42.00, and then I'm going to write 26. And I'm going to actually use the entire number that's located inside of my calculator, and I'm going to show you a shortcut for that in just a second. Now I need to get b alone, so I'm going to take the square root of both entire sides, and so I end up with what the value of b is. So what I'm going to do is I'm going to put this entire number of 42.00260022 into my calculator by pressing second and square root. So I'm going to go down to my square root button. So now we see the square root has appeared. And I'm going to press second and then the negative button. So if you come down here to where it says ANS means your previous answer. And if you press second and then your negative symbol, it's now going to take ANS. And I'm going to close my parentheses because I'm going to take the square root of 42.00260022. And I end up with 6.48 is my answer. And so that's going to be 6.48 units. And so that's just a little quick shortcut to save you a few seconds on your homework. So what's cool now is that I know what little b is. So I now officially have two of a kind. But my issue is I need to find what angle A and angle C are, and I need to figure out, do I want to work with the law of cosines or do I want to work with the law of sines now that I have two of a kind? It's your choice. So it says, please, I have this little box and then a little aside, so if you want to pause the video to write this down, that might be a good thing for you to write down. It says, when you know all three sides and one angle, which is where we're at right now, we know all three sides and we know one angle. You can use the law of cosines or you can use the law of sines to find the measure of the second angle. It's your choice. You can use either one. Please note that if you decide to switch to the law of sines, so you use the law of cosines to find your missing side, and now you want to use the law of sines in order for you to find your missing angles, that's fine. It can be technically shorter if that's the way that you view it. But you have to make sure that you find the smallest angle first, because your calculator always gives an acute answer when working with the sine function. So please know that your calculator and the sine function always produce acute answers. So what that means is that if you're going to find an angle, you want to make sure you find your smallest angle, because if you find your largest angle, that largest angle might end up being obtuse, and if it's obtuse, we won't be able to tell based on our calculator's answer. So that's something to keep in mind. I'm still going to switch over to the law of sines. I think it's a little bit faster. And my smallest angle, based on what's remaining, is going to be angle A. Do you see how angle A is across from little 7, or angle, I'm sorry, the side that is 7 versus angle C is across from 12? Since angle C is across from 12, that indicates that it's going to be our biggest angle out of them. So I'm going to identify what my smallest angle is, which is angle A. So this is my first step, identifying what little b is. Here's my step. The second step, I'm going to identify my smallest angle. So I'm going to find the smallest angle, which just so happens to be the measure of angle A. So the measure of angle A, I'm going to work with the law of sines in order for me to do it. So that means I'm going to work with my given information. So that's going to be my B information. So that's 6.48 divided by the sine of 26. And that's going to be equal to 7 divided by the sine of angle A. I'm going to use cross product, and I end up with 7 times the sine of 26 is equal to 6.48 times the sine of angle A. I'm going to divide both sides by the 6.48. And now what I'm going to do is I'm going to take the sine inverse so that I can find what the measure of angle A is. So measure of angle A is going to equal the sine inverse of 7 times the sine of 26 divided by 6.48. And when I put that into my calculator, I find that the measure of angle A is equal to 28 degrees. So now I know what the measure of angle A is, and now I need to find what the measure of angle C is. And since I already know my 2 out of the 3 angles, I'm just going to use the 180-degree rule. So my step 3 is to find the measure of angle C, which is going to be equal to 180 minus 26 minus 28. And 26 minus 28, taken away from 180, is equal to 126 degrees. Excuse me. And there is our answer. We've officially solved this triangle. So that's what happens when you're given side, angle, side. So now what we're going to do is we're going to work with side, side, side. So our next example, we are told that little a is equal to 7, little b is equal to 13, and little c is equal to 9. So I'm just going to label my triangle. And whenever you are given side, 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 the first thing that you want to do is you want to identify what your largest angle is. And the reason why you want to find what your largest angle is you need to make sure that the other 2 angles are acute. The reason why you want to make sure that the other 2 angles are acute is so that you can have your choice of working with the law of sines or working with the law of cosines. So the first thing that we do is we need to identify the angle that is opposite of the longest side. And our longest side is AC. We know that because 13 is the biggest. And the angle that is opposite is angle B. So we are going to identify the measure of angle B first. So in side, 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 it is very important to find the largest angle first. So that's very important for us to do. And it says in example 2, the largest angle is found first to make sure that the other 2 angles are acute. This way, when you use the law of sines to find another angle, you will know that it is in between 0 and 90 degrees. So that's the reason why we do that. Now, we don't know that that angle B is going to be obtuse, but we do know that it's going to be bigger than the other angles. So that's the one thing that we do know. So I'm going to use that formula to find the measure of angle B. that we talked about on the front page, and that's going to be the measure of angle B is equal to the cosine inverse of my other two sides, which is going to be a squared plus c squared. I'm going to subtract away my opposite side, which is b squared, divided by 2ac. So I'm going to use this formula, and I'm going to identify that the measure of angle B is equal to the cosine inverse of a squared, which is 7 squared, plus c squared, which is 9 squared, minus 13 squared, divided by 2 times 7 times 9. And I'm going to put that into my calculator exactly as I see it because it's all numbers. So I'm literally going to put into my calculator the cosine inverse of parentheses. I'm going to put double parentheses to establish that this is my numerator and then my denominator. So what might be helpful before I even do anything is just to put in my numerator into my calculator so I know what that value is. So I'm going to go 7 squared plus 9 squared minus 13 squared. I think this might be easier. So I'm just putting my numerator into my calculator and I end up with negative 39. So I'm going to write this as the cosine inverse of negative 39 divided by. And now in my denominator, I'm going to put 2 times 7 times 9. And that's my denominator, and that's 126. So I think it might be easier to put into your calculator the cosine inverse of negative 39 over 126 instead of messing with that whole thing to be put into your calculator. You want to make sure that you get the right answer and not try to save yourself too much time. So I'm going to go negative 39 divided by 126. I'm going to take the cosine inverse of that fraction, and I end up with my answer being 108. We want to round this to the nearest whole number. So I found that the measure of angle B is equal to 108 degrees. So since we're solving triangles, we want to identify what the measure of angle A is, what the measure of angle B is, and what the measure of angle C is. And so far, I know that the measure of angle B is equal to 108. I already know what little a is. Little a is equal to 7, little b is equal to 13, and little c is equal to 9. And I'm going to put little UNs at the very end because we're talking about units. So then the next thing that we want to do is we want to identify what our other two angles are. And you have a choice. Now that we know that angle B is equal to 108 degrees, we now need to, we can work with the law of sines. We can work with the law of cosines. In our last example, we worked with the law of sines. So why don't we just work with the law of cosines? So I can find our next biggest angle. Our next biggest angle would be angle C because it's across from our next largest side. So I'm going to find the measure of angle C. So identifying the measure of angle C, that's going to be equal to the cosine inverse of a squared, which is 7 squared, plus b squared, which is 13 squared, minus our opposite side, which is 9 squared, divided by 2 times 7 times 13. So just like I did before, I think it might be in your best interest to probably identify what your numerator is, and then your denominator, and then take the cosine inverse of that whole fraction. So I'm going to put in 7 squared plus 13 squared minus 9 squared. And when I put that into my calculator, I end up with 137. So that's going to be 137 divided by, when I put 2 times 7 times 13 in my calculator, I end up with 182. And when I take the cosine inverse of 137 divided by 182 and round it to the nearest whole number, I end up with 41 degrees. Cool. So I know that the measure of angle C is 41 degrees. So now if I want to find what the measure of angle A is, I'm going to be using inverse. Or not inverse. I'm going to be using the 180 degree rule. So next, to find the measure of angle A, I'm going to say 180 minus 108 minus 41 will give me the measure of angle A. And if I were to put that whole thing into my calculator, I would end up with 31 degrees is equal to the measure of angle A. And that is it. We've officially solved our triangle. So now what we're going to do is we're going to once again be given side, 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 and we need to identify our missing angles. So I'm going to draw this triangle, recognizing that side A is the largest side, so I'm just going to kind of keep that in mind when I draw my triangle. I'll make this side A, and here's little a being 23. I'll make this side B, and I'll make this side C. So that would mean that little c would be down here at 20, and little b would be over here at 18. Okay, so I want to identify the measure of angle A, the measure of angle B, and the measure of angle C. I already know that little a is equal to 23, little b is equal to 18, and little c is equal to 20, and I'm going to put little units at the very ends of all of those. So my biggest angle is what I want to find first because I'm given side, side, side. So that means the angle I'm going to identify is angle A since it's across from our largest side. So identifying the measure of angle A, I'm going to write that the measure of angle A is equal to the cosine inverse of my other two sides, which is 18 squared plus 20 squared minus my opposite side, and my opposite side is 23 squared, divided by 2 times 18 times 20. I'm going to identify my numerator and denominator individually, and so 18 squared plus 23 squared minus 20 squared, that's equal to 453, divided by 2 times 18 times 20, I think, times 20, that's equal, I'm sorry, I think I did that one incorrectly. 18 times 20, or 18 squared plus 20 squared minus 23 squared, that is equal to 195, sorry about that. And 2 times 18 times 20, that is equal to 720. And when you put that fraction into your calculator, you're going to end up with your answer equaling 74 degrees. So the measure of angle A is equal to 74 degrees. So let's go ahead and identify our next biggest angle. So our next biggest angle is going to be angle C, and that's because it is across from our, it's the next largest side. So an angle C is across from our next largest side. So that's what I'm going to identify next, the measure of angle C. And once again, I'm going to work with the law of cosines. You can work with the law of sines, that's not a big deal, but I'm just going to write the cosine inverse of my other two sides, which are going to be 23 squared plus 18 squared minus 20 squared divided by 2 times 23 times 18. And so that's going to be the cosine inverse of, now we have 453, and that's going to be divided by 828. And when you take the cosine inverse of that fraction, you're going to end up with 57 degrees. So we know that the measure of angle C is 57 degrees. So now I can identify what the measure of angle B is by using my 180 degree rule. So the measure of angle B, that's going to be equal to 180 minus 74 minus 57. And when you put that into your calculator, you end up with 49 degrees. And now you have officially solved this triangle for side, side, side. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.